In this video, we will practice using trigonometric identities to rewrite expressions in equivalent forms. This is AP Precalculus Topic 3.12. If you appreciate the content, please give it a like. In a previous video, we learned these trig identities. Pause the screen and practice writing them from memory. On the AP exam, no formula sheet will be provided, so you better make some flashcards or something. From this point forward, I'm going to assume that you have memorized these. Pause the screen and verify that you know all of these basic identities as well. Simplify the following expressions and match your answer with one of the answers in the box above. Each answer should be used exactly once. Be sure to show all appropriate work that leads to your answer. There is more than one way to simplify a trig expression, and our number one strategy is to rewrite everything in terms of sine and cosine. However, I'm noticing that we have tangent squared and secant squared in this expression, and that reminds me of one of our identities. One version of the Pythagorean identity goes like this: tangent squared theta plus 1 is equal to secant squared theta. So let's try making this substitution and see what happens. I'm going to put tangent squared theta plus 1 in for secant squared theta. Be careful, because of the negative sign, this binomial needs to be written inside of parentheses, otherwise it is not algebraically correct. Next, we distribute the negative sign, and the parentheses will go away. For number 2, I think I will use our favorite strategy of rewriting everything in terms of sine and cosine. We already have sine and cosine, so I just need to rewrite tangent as sine theta divided by cosine theta. And then that is times the sine theta. Alright, maybe I'll put sine theta over 1 just for fun. Plus cosine theta. You know, I think I'll even write that as cosine theta over 1. Let's just keep everything as a fraction. On the next step, I see that we have sine squared theta over cosine theta, multiplying straight across. Okay, but as I get ready to write this term over again, I would like to have like denominators. So let's multiply by cosine theta over cosine theta. So that way we will have like denominators. So on the next step, we will actually have cosine squared theta over cosine theta. Now we have like denominators, so we can add these two fractions together, and we will get sine squared theta plus cosine squared theta over the common denominator of cosine theta. Aha! This is our favorite Pythagorean identity. We know that sine squared theta plus cosine squared theta is equal to 1. So this is 1 over cosine theta. Okay, I'm out of space here, so I'm going to go horizontal. We know that 1 over cosine theta is secant theta. So let's see if secant theta is one of the options. There it is. It's option B. So that's the answer to number 2. Number 3. Look at that denominator, 1 plus tangent squared theta. What does that remind me of? One of the versions of our Pythagorean identity goes like this: tangent squared theta plus 1 is equal to secant squared theta. Hopefully you have memorized this. So I'm recognizing that 1 plus tangent squared theta is equivalent to secant squared theta. So I'm going to make that substitution. So on the next line, we will have tangent squared theta divided by secant squared theta. From there, I'm going to fall back on my favorite strategy, which is to rewrite everything in terms of sine and cosine. Tangent squared theta can be rewritten as sine squared theta over cosine squared theta. And then secant squared theta is 1 over cosine squared theta. What we have here is a fraction divided by another fraction. When you divide by a fraction, you multiply by the reciprocal. So I'm going to recopy my sine squared theta over cosine squared theta. But now I'm going to multiply by the reciprocal, which will be cosine squared theta over 1. Notice that the cosine squared theta in the denominator will cancel out the cosine squared theta in the numerator, leaving behind only sine squared theta. I wonder if that's one of the options. And there it is. Option D. So that's the answer for number 3. Is it weird that I think this is fun? These are like puzzles, guys. So forget about the fact that this is homework or math, something that you're going to be tested on. These are fun little puzzles. Play it like a game. So on number 4, I think I'm going to fall back on our favorite strategy of rewriting everything in terms of sine and cosine. Tangent theta can be written as sine theta divided by cosine theta. And cotangent theta can be written as cosine theta divided by sine theta. When I have two fractions that are being added or subtracted, my instinct is to form like denominators. I'm going to slide this over a bit to make room. So in order to make like denominators, I'm going to multiply the first fraction by sine theta over sine theta. And I'm going to multiply the second fraction by cosine theta over cosine theta. Now we will have the common denominator, sine theta, cosine theta. So adding these two fractions together, we get sine squared theta plus cosine squared theta divided by sine theta, cosine theta. I see what's happening, yeah. Sine squared plus cosine squared is our favorite Pythagorean identity. This always is equal to 1. So what we have is 1 over sine theta cosine theta. I don't think there were any fractions among the answer choices. So let's flatten this out. 1 over sine is cosecant, and 1 over cosine is secant. So this will be the same thing as cosecant theta times secant theta. I think I saw that as one of the options. Alright, well, that's the same as secant theta times cosecant theta. So the answer is G. To be on the safe side, I should probably follow through and rewrite this in the same order as what we see in the answer box. So equals secant theta times cosecant theta. And then the answer is G. Moving on to number 5, I think I'm going to use our favorite strategy of rewriting everything in terms of sine and cosine. Secant theta is 1 over cosine theta. Tangent theta is sine theta over cosine theta. And then times sine theta, which I will write as sine theta over 1. We appear to have like denominators immediately. So I'm going to go ahead and combine these two fractions together. We have 1 minus, and of course sine theta times sine theta is sine squared theta. So 1 minus sine squared theta in the numerator divided by cosine theta. 1 minus sine squared theta reminds me of our primary Pythagorean identity that goes sine squared theta plus cosine squared theta is equal to 1. If I were to subtract sine squared theta from both sides, we would get cosine squared theta is equal to 1 minus sine squared theta. So 1 minus sine squared theta is equivalent to cosine squared theta. Let's make that substitution. Now we have cosine squared theta over cosine theta. The cosine theta in the denominator will cancel out one of the cosine thetas in the numerator, leaving behind simply cosine theta. Let's see if that's one of the options in the answer box. And there it is. The answer to number 5 is H. Number 6, cosecant squared theta minus 1 reminds me of one version of the Pythagorean identity. It reminds me of the version that goes cotangent squared theta plus 1 is equal to cosecant squared theta. Let's see, so here we have cosecant squared theta minus 1. So if I subtract 1 from both sides, we get cotangent squared theta is equal to cosecant squared theta minus 1. So let's make this substitution. I'm going to put cotangent squared theta in instead of cosecant squared theta minus 1. So in the numerator we will have cotangent squared theta. In the denominator we have cosecant squared theta. Next, I want to rewrite everything in terms of sine and cosine, as I love to do. Cotangent squared theta can be written as cosine squared theta divided by sine squared theta. And cosecant squared theta can be written as 1 over sine squared theta. When you divide by a fraction, you multiply by the reciprocal. That's cosine squared theta over sine squared theta times sine squared theta over 1. Now we notice that we have sine squared theta in the denominator and in the numerator. So these will cancel each other out, leaving behind only cosine squared theta. And that is option F. So that's the answer to number 6. For number 7, a valid strategy would be to rewrite everything in terms of sine and cosine right from the start. However, I'm noticing that cosecant theta and sine theta are reciprocals of one another. Also, cotangent theta and tangent theta are reciprocals of one another. So I'd like to play around with that and see if we can use that relationship to simplify the expression. For example, what if I took the cosecant theta and sort of wrote that off to the side? That would leave behind, so we would have cosecant theta times 1 over sine theta. Can you see how this is the same as cosecant theta over sine theta? Similarly, if I take the cotangent theta and sort of pull that off to the side, that's going to leave behind 1 over tangent theta. So we will have 1 over tangent theta times cotangent theta. The point of this is that I have now revealed that we have cosecant theta times 1 over sine theta, but wait a minute, 1 over sine theta is another cosecant theta. So on the next step we can write cosecant theta times cosecant theta minus. Similarly, 1 over tangent theta is another cotangent theta. So we have cotangent theta times cotangent theta. Of course, this is cosecant squared theta minus cotangent squared theta. This reminds me of the version of the Pythagorean identity that goes cotangent squared theta plus 1 is equal to cosecant squared theta. Let's see. I'm trying to see how I could create this expression. I see the cosecant squared. I want cosecant squared theta minus cotangent squared theta. So let's subtract cotangent squared theta from both sides of this identity. That will leave 1 is equal to cosecant squared theta minus cotangent squared theta. So if we make this substitution, we are done. So this expression is equivalent to 1. And that is answer choice C. That's it for number 7. For number 8, I feel like we're going to have to FOIL this out. So sine theta minus cosine theta squared can be, of course, written as sine theta minus cosine theta times sine theta minus cosine theta. And I feel like we have to do the same thing for sine theta plus cosine theta. So I'm going to put this plus in the middle that you see right here, but I'm going to write it twice. By the way, a common mistake is to think that you can just square each one of these individually and replace this expression with sine squared theta plus cosine squared theta. But this is bad algebra. Do not do this. Instead, you have to write it twice, and then we are going to FOIL this, first, outer, inner, last. Or you can think of it as doing the distributive property twice, once with the sine and again with the cosine. First, we got to multiply these two. Sine theta times sine theta is sine squared theta. Okay, outer, we have negative sine theta times cosine theta. I'm going to leave a little space here. Because inner, we have another negative sine theta cosine theta. So because we have two of them, I can just put a 2 right here. I'm combining like terms as I go. That brings me to multiplying these two. A negative times a negative is a positive. So we have positive cosine squared theta. So this is what we get from multiplying these two binomials together. So let's do something similar right here. I think I'm going to switch colors just to make it more clear what's happening. Sine theta times sine theta is sine squared theta. And then sine theta times cosine theta. I'm going to leave that space again. Okay, we have sine theta times cosine theta. So then it's time to multiply cosine theta times sine theta, which is another sine theta times cosine theta. So because that's another one, I can combine them and just write 2 sine theta cosine theta. And then finally we have cosine theta times cosine theta, which is cosine squared theta. So, scanning back and looking for like terms, I see that we have sine squared theta plus sine squared theta. That is 2 sine squared theta. 2 of those going on. Then I see that we have negative 2 sine theta cosine theta plus 2 sine theta cosine theta. So those are going to cancel each other out. Moving on, I see that we have cosine squared theta plus cosine squared theta. So that's going to be 2 cosine squared theta. So we have plus 2 cosine squared theta. But, this is reminding me of our favorite Pythagorean identity, sine squared theta plus cosine squared theta is equal to 1. Except we have these 2's in here. Well, those 2's are a common factor, and we can always factor out that GCF outside of parentheses. That will leave behind sine squared theta plus cosine squared theta, which is equal to 1. And of course 2 times 1 is 2, which of course is the only remaining answer choice. And the answer to number 8 is E. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.